Hey everyone, welcome back to Tutoring by Alejandro. So today we're tackling an SAT math topic that many students struggle with, which is systems of linear equations. So I brought three examples. The first one is a system with one solution, the second a system with infinite solutions, and the third is a system with no solution. Hopefully by the end of this video, you'll know exactly how to tell the difference. You'll know what the meaning of a solution is, right? And you'll be confident enough to tackle these types of problems on your SAT exam. Okay, so we have two equations, right? An equation can be rewritten as a linear function, right? Because we're dealing with linear equations. And you can see that on the right, where you have y is equal to mx plus b, right? Now, you can plot these two functions, right? Because each linear equation can be, again, organized into a linear function. And you see a blue function and a red linear function. And our solution is any point where those two functions touch, okay? So, as I alluded to before, they can either, if we're dealing with linear equations or linear functions, you can have a scenario where they'll touch at one point, they'll touch at infinite points, which we'll get to later, or they won't touch at all. Okay? So let's take a look. So a solution is any ordered pair, right? Because this purple point here that says solution is an x comma y pair, such that if you substitute it in both equations, you'll end up with a true statement. And what do I mean by a true statement? I mean something like this. So if you evaluate the left side, let's say you get 3, right? And once you're done doing your math, evaluating the right side, you also get 3. 3 is equal to 3, and that is true, right? So that's what I mean by a true statement. Where after evaluating both sides, you end up with the same value, okay? Another example, right? I evaluate the left side, I end up with 2, and then I evaluate the right side, I also end up with 2. That's a true statement. So what's a false statement? One where if I evaluate the left side, for example, I end up with 5, but if I evaluate the right side, I end up with 2, right? 5 is not equal to 2, so that is a false statement. So I'll know that I have the right ordered pair if after substituting the values in both equations, I end up with 2 true statements, okay? So that's what I mean by a solution. Okay, so there are many ways of solving a system of equations. There's substitution and there's elimination, which I believe are the ones that you will most likely implement on your SAT exam. There's also graphical, but I don't think you're going to have the time to do that. And there are some more advanced ones, which you typically don't cover in a standard algebra course. Okay, so let's rewrite these equations. So we have y equals 2x plus 4. Okay, the second one is x minus y equals negative 1. I want to rewrite both equations to get them in the form of a linear function. Namely, y is equal to mx plus b, right? Or have the first y directly on top of the second y, right? The x on top of the x and all the numbers on top of the other numbers, okay? So doing that requires me to do some manipulation, okay? If you recall the previous video, isolating variables, right? One way of isolating the y is apply the opposite operation, right? The y is negative, so if I add y on both sides, I'll end up with just x, right, is equal to -1 plus y, right? Because the y's on the left cancel out, okay? All right, now I have my positive y, but I still have a -1 there. I want to get rid of that -1, right? I want the y's on one side and everything else on the other. So the -1 is, like I said, negative, right? So it's subtracting. So I'm going to add 1. Oops. I'm going to add 1 on both sides. Okay. So now that -1 and that +1 will cancel out, and I'll be left with y is equal to x plus 1. Okay? So let me just rewrite that so it looks a bit cleaner. Y is equal to x plus 1. Okay, so this is what I was talking about. I have my y on top of my y, my x on top of my x, and the numbers on top of the other numbers, right? Okay. So I'm going to apply, in this case, elimination, right? You can apply substitution. I may even do both, but let's do elimination. So how does it work? You want to, in the end, add or subtract these two equations in order to get a variable to cancel out, okay? So for example, I have a y up here and a y down there. So what happens if I multiply my second equation by -1? So doing that, remember, I have to apply it on both sides. So I'm going to apply -1 on the left, and I'm going to apply -1 on the right. So remember to apply it to every single term, right? And I will end up, after manipulation, with -y is equal to -x minus 1, okay? So let's get rid of that to make it a little cleaner. Okay, great. So now I have my first equation and my second equation. And if I add them up together, let's see what happens. So I have y minus y, right, is equal to 0, okay? They just cancel out. That's equal to. Now I have 2x minus x, right? I have to subtract the coefficients. So I have a 2 here and an invisible 1 here, right? So that's 2 minus 1 equals 1, right? Since the 2, which is positive, is greater than the 1, which is negative, I'm going to end up with a positive 1x, right? And I don't need to write the 1, okay? And finally, I have plus 4, or positive 4, minus 1, right? Which is, again, the 4, which is positive, is greater than the 1, which is negative. So I end up with positive 3, okay? So now I'm going to isolate the x. So I need to get rid of that plus 3. So I apply the opposite operation, which is subtraction. And I have to apply it on both sides. So -3 on the right and -3 on the left. And I'm left with x equals -3. Okay. So now I have my x value. And how do I obtain the y value? I'll substitute that x value in any of those two equations. I'll choose the bottom one, just my preference. You can do the top one if you want. So plugging into the second equation gives me -3 minus y is equal to -1. Okay. Let's isolate the y now. Let's get rid of the -3. So the -3 is subtracting, right? Because it's negative. So I'm going to add 3 on both sides. The 3's cancel out on the left, and I'm left with -y is equal to -1 plus 3 is positive 2, right? Because the positive 3 is greater than the 1, which is negative. And now I can simply multiply by negative 1 on both sides to get rid of that negative on the y. And I am left with y is equal to negative 2. Okay? So my solution to this system, putting it all together, is negative 3, comma, negative 2, which is B. Okay? So how do I validate that that is the solution, right? Aside from the fact that we, did all this math. So remember, we want two true statements. So I'm going to plug in that negative 3, comma, negative 2 into both equations, and I should end up with two true statements. So let's do the top one first. So I have, so remember, this is my x, this is my y. I have negative 2 equals 2 parentheses, negative 3 plus 4, right? Okay. Let's evaluate the right. So now I have 2 times negative 3 is negative 6 plus 4. Okay. Now I have negative 6 plus 4. So since they're different signs, meaning one is positive, one is negative, I subtract the values. So 6 minus 4 equals 2. And the sign, remember, goes to, it has the same sign as whichever value is greater. So the 6 is greater and it's negative, so I end up with negative 2. Negative 2 equals negative 2 is a true statement. Okay, so let's evaluate the second one. So now I have x, which is negative 3, right? Minus y, which is negative 2. So remember, whenever you have a negative and a negative, make sure that you include the parentheses. Okay. And that's equal to negative 1. Okay, so now I have negative 3. Whenever you have a negative and a negative right next to each other, that evaluates to positive. So now I have negative 3 plus 2 equals negative 1. And similarly to what happened with the negative 6 and the plus 4, I will end up with negative 1, right? I subtract the value, so 3 minus 2. And since the 3 is greater than 2, I adopt the same sign, right? So as the 3. So negative 1 equals negative 1 is a true statement. So again, this is indeed the solution to this system of linear equations. Okay, great. Let's move on to the next one. All right. So now we have, which of the following systems of equations has infinitely many solutions? So in our first exercise, we had a system of linear equations with only one solution. This time, they're saying it has infinite solutions. What does infinite solutions mean? So when there was one solution, graphically, you would see two functions touching at just one point. Each point where the two functions touch is considered a solution. If there's infinite solutions, that means those two functions are going to touch at every single point, which is why graphically what you see on the right, you see I drew the red function right on top of the blue functions. That means they are going to touch at every single point, which essentially means if you do some math, even though it may not be obvious in the beginning, you're dealing with two functions that are exactly the same, right? So let me just give you a quick example off the top of my head. So let's say you have y is equal to mx plus, sorry, not m. Y is equal to x plus 1, right? That's our first one. So let's say our second one is 2y is equal to 2x plus 2. If you divide the second function by 2, remember you have to do it on both sides, you'll end up with 2 divided by 2 equals 1. So that's y equals 2 divided by 2, again, is 1. So that's x. And then you have 2 divided by 2 is 1. So after some math, you'll end up with y equals x plus 1. Basically the exact same function as the first one. So that means you will have infinite solutions. They're going to touch at every single point. No matter what value you give to x, you'll end up with the same y value. Okay? So that's what we need to find out and when we're evaluating those 4 answer choices. Okay, so let's see what we can eliminate as being the correct answer right away. So my eyes jump to answer B, right? You have negative 2x plus y equals 1, and then you have negative 2x plus y equals 5. So there's no amount of math you can do where you'll end up with the same function, right? Just because of that 1 and that 5, right? So that eliminates B from being the right answer, right? They're going to have different intercepts, right? Which is the B value. Okay, let's see what else we have. Answer A may not be as obvious as B, but I can already tell that that's not the right answer, because if you isolate y from both equations, right, you're going to end up with, the first one is y is equal to, the x is positive, so I'm going to subtract x on both sides, leaving me with negative x plus 1, right? Now, on the second one, I'm going to have, again, subtract x on both sides. So I'm going to have negative y is equal to negative x plus 1. But now I have to get rid of that negative, right? So that means I have to multiply by negative 1 on both sides, which gives me y is equal to, you're essentially flipping the signs for everything, right? So instead of negative, you're going to end up with positive x and negative 1, right? Again, those are not the same functions, so A is eliminated from consideration, okay? All right, so I'm left with C and D. So what I want to do is I want to get these equations to adopt the form, remember, y equals mx plus b, which is the slope-intercept form when we want to express it as a function. Okay, so I'm going to isolate y. Let's get rid of that x from the left. So I can subtract 1/2 x from both sides, right? Let me just rewrite this. Okay, these two cancel out, and I'm left with negative 1/3 y equals 1 minus 1/2 of x. Okay, all right. So now I have the negative 1/3, which is multiplying the y. I want to get rid of that. So I'm going to divide by negative 1/3 on both sides. Okay, and so remember, when you're dividing by a fraction, what you do is you flip it over, right? And remember, whatever you do on the left, you do on the right. Okay, and I'm just writing that 1 for just some extra illustration. You don't need that 1, right? Okay, so on the left side, these cancel out, right? Because they equal to 1, right? So that leaves me with y equals, and now I have what is essentially negative 3 times 1, right? You have two different signs because the 1 is positive and the 3 is negative, so that ends up with negative. And then 3 times 1 is 3, right? Now I have negative 3 times negative 1/2 x. So now I have a negative times a negative. Whenever I have two numbers multiplying that have the same sign, I end up with a positive, right? So now I have 3 times 1/2. So let me just do this to the side right here in this little box. 3 times 1. I'm going to 1/2, sorry. Whenever you have multiplication of fractions, you do it face to face. So now I have 3 times 1 equals 3, and then 1 times 2 equals 2. So I'll end up with 3/2 of x, okay? So reorganizing that gives me y is equal to 3/2 x minus 3. Okay, so that's the first equation. So let's see what happens with the second one. Okay, so we have 3x minus 2y equals 6. Okay, so again, I'm going to get rid of the 3x. It's positive, so that means it's adding. So I will subtract 3x on both sides. Okay, the 3x's cancel out, and that leaves me with 2y equals 6 minus 3x, right? Now, to get rid of the negative 2, the negative 2 is multiplying the y, so I'm going to divide by negative 2 on both sides. And remember, I have to do it to every single term. Okay, so now negative 2 divided by negative 2 just leaves me with y. And now on the right side, I have to divide each term by negative 2. So first I have 6, which is positive, divided by negative 2. Since they have different signs, meaning the 6 is positive and the 2 is negative, I'm going to end up with a negative number. And then I do 6 divided by 2, which is 3. Okay? Now for the second term, which is the negative 3x, I have negative 3x divided by negative 2. Since they are of the same sign, meaning both are negative, I end up with a positive number. And now I just have 3x divided by 2, which leaves me with 3/2 of x. Okay? Reorganizing that leaves me with y is equal to 3/2 of x minus 3, right? And if you look closely, I end up with the same function as the previous one. So I end up with y equals 3/2 of x minus 3 for both the top and the bottom equation. So that means that our answer in this case is C, since they are the same functions and therefore they have infinite solutions because, they touch at every single point. Okay, good. Let's move on to the next one. All right, so this is our last exercise. We already tackled a system of linear equations where there is only one solution, right? That means the functions only touch at one point. We saw what happens when there are infinite solutions, right? Which means when the equations are modified to the slope-intercept form, they are essentially the same function, right? Now, what happens if there's no solution? So when there's no solution, after you quote-unquote converted the equations to functions, two conditions have to be met. And it'll make sense once you see the graph. So the first one is the slopes. The slopes have to be the same, right? So if one function has, let's say, a 45-degree slope, the other one also has to have a 45-degree slope, okay? And our second condition is that the intercepts, so that point where the function touches the y-axis, right? Those have to be different, okay? And if you summarize this, it essentially means that the two functions have to be parallel, okay? If they are parallel, that means as x increases, right, you keep giving x different values, they're going to be mirroring each other, right? But they'll never have the same y value because they have different intercepts, right? So those are the two conditions that have to be met for the functions to never touch each other, right? They have to be parallel. So same slope, but different intercept. If they have the same slope and the same intercept, you'll end up with what happened in the previous exercise, where there are infinite solutions, right? Because they're going to touch at every single point. So it's very important that the intercepts are different in this case, right? Okay, so let's reorganize our equations to the slope-intercept form, okay, which means we're going to isolate y, okay? So from the first one, we have 14x minus ay equals negative 9/2, okay? So I am going to, let's subtract 14x from both sides, right, to get rid of it. And that means I'm going to have 14x minus a times y. And then let's write this in red, because that's what I'm doing to the equation, equals negative 9/2, right, minus 14x, okay? The 14x's on the left cancel out, right, because one is positive, one is negative. And now I'm left with negative a times y equals negative 9/2 minus 14 times x, okay? Now I have to get rid of the negative a from the left side. So the negative a is multiplying the y. So I'm going to divide by negative a on both sides, right? So, and whatever I do, right, whatever I do on the left, I have to do it on the right. So let's do that. Okay. Again, dividing by negative a is the same as multiplying by 1 over negative a, okay? So the negative a's on the left cancel out, and I'm left with y equals, so now I have my negative 1 over a multiplying both terms. So let's do the first one. I have negative 9 over 2 multiplied by negative 1 over a, okay? I have a negative multiplied by a negative. That means my result is going to be positive. And then I multiply face to face, right? The numerators. So 9 times 1 is 9. And then I have 2 times a is just 2 over a, right? So that means I have 9 over 2a, okay? So let's do the next one, the other term. I have negative 14x, which I can rewrite as negative 14x over 1. Let's make this parentheses a little bigger. Multiplied by negative 1 over a, right? Again, I have two negatives. A negative multiplied by a negative, so my answer is going to be positive. I multiply face to face, so I'm going to have 14x times 1 is just 14x. And that's going to be divided by 1 times a is just a, right? And my answer is going to be positive, right? So that is 14x over a. Okay. Let me do a little reorganizing. And I'm going to be left with y equals 14 over a times x plus 9 over 2a. Okay, so that is my first equation converted to a function in the slope-intercept form. Okay, that's the first one. So let me make some space here to tackle the second one. Oops, Okay, so now I have 7 halves of x minus y equals negative 1/4. So to get rid of the 7 halves x on the left, I'm going to subtract, right, by 7 halves of x on both sides. So they'll cancel out on the left, right? And I am left with negative y on the left, and on the right side, I'm left with negative 1/4 minus 7 halves x. Okay? Okay. Now I'm going to get rid of that negative on the left, right? Which is a negative 1 multiplying the y. To get rid of it, I'm just going to multiply both sides by negative 1, right? Okay. So that means I got rid of the negative on the left. That means I'm left with y equals. So I apply the negative 1 on both terms, which just means I'm going to switch up their signs, right? If they're negative, they're now going to be positive, and vice versa. So the 1/4 is negative, so now it's going to be positive. And same goes for the 7 halves of x. Okay. Okay, great. Just reorganizing it, I'm left with y equals 7 halves of x plus 1/4. Okay, so these are my 2 equations converted into this slope-intercept form. Okay. So I have to figure out what the value of a is. And how do I know what value of a I need? I need to ensure that I end up with the same slope, but different intercept. Okay? All right, so the slope of the first function, or m1, is 14 over a, right? And the slope of my second function is 7 halves, okay? So I need to make sure that 14 over a is equal to 7 over 2. Okay, so I'll solve for a. How do I solve for a? Okay, so when you have this situation here, what you do is you're going to multiply the diagonals, right? So that means my a is going to be equal to 14 times 2. Okay, and then you're going to divide by whatever's diagonal to the a. So that means divided by 7, right? This gives me 14 times 2 is 28. And 28 divided by 7 gives me 4. Okay? So if a equals 4, I end up with 14 over 4, right? 14 over 4, if I simplify that by dividing by 2 in the numerator and the denominator, I end up with 14 divided by 2 is 7, and 4 divided by 2 is 2. And 7 halves is equal to 7 halves. So I have the same slope. Do I have different intercepts? So my first intercept from the first equation is 9 over 2a. And a is 4, right? We calculated it to be 4. So that means the intercept for the first equation is 9 over 8. And 9 over 8 is different than 1/4, right? Because even if I multiply 1/4 by 2 in the numerator and the denominator, right? I'll end up with 1/4 is the same as 2 over 8, which is different than 9 over 8. So I met both conditions, right? The slopes are the same, but the intercepts are different. So that means our value of A is indeed 4. Okay? So those were the 3 exercises. Just sort of showing you guys the 3 situations you can encounter on your SAT math exam. If you'd like some extra practice, I have 2 exercises for you. The first one is just you have to find the solution to the system of equations, but they are asking for the value of x plus y. So when you're doing these exercises, make sure you read the fine print. Sometimes they don't ask you for a solution. They'll ask you for a little variation of it. In this case, you just have to add up the values of x plus y. But a lot of students, if they're rushing through the exam, they won't read that. So they'll get it wrong. I know you won't. Okay, and then the second one, I just have a system of linear equations with no solution and another constant. Very similar to the one we just did. So you just have to find the value of k. All right. So I hope this was very helpful for you guys. If it was, please subscribe. Please give this video a like. If you need some extra help, I'm trying to promote my tutoring website. I offer private tutoring, group tutoring, okay, all online. So please check that out if you need some extra help. So thank you guys again, and I'll see you on the next video.